Hi and welcome. This video is gonna be designed and made to kind of go over all the different tools we use in the machine shop here at Lake Park High School. We're gonna kind of work our way around. I might rearrange some things. I might put this guy down here at the end. The most common tool we use at the shop is this one down here at the end. This is a diamond insert. The reason why we use this all the time is diamond. I'm not going to go into a whole bunch of technicalities. I'm just going to go into what you need to know. We use this diamond insert a lot because it can turn small diameters that need to be supported with the live center. And that's a lot of our work. A lot of the work we do needs to be supported with live centers. We use this tool all the time. It's the most common tool in the machine shop we use at Lake Park High School. Probably the second most common tool that we use all the time, very frequently in the machine shop, are really probably the next three. The next three are really common because every part we make, we use every project we make or part we make, we use what's called the parting blade or the parting tool. This is a cutoff tool to cut off our parts. And this is what it kind of looks like. It's very flat and a very delicate tool. This is one of the weakest tools in the shop because there's just not much material holding it, supporting the tooltip. The tooltip where you're going to be cutting with this is right here, the end of the very end where the insert is held in this metal piece. You can see that the insert is not very big, and the insert is made out of carbide on all these tools except for this one, which I believe I order cobalt wheels, knurling wheels, and this is another carbide insert. And on this tool, this tool is our general turning tool. It's going to do all of our cutting. The part that's going to do the cutting is right here at the end of our insert. Most of it should be cutting from the middle of the round and around this way. As soon as you start cutting on the back side of the insert, we end up getting a lot of chatter. But the part of the insert we should be cutting on is like right here where my fingernail is. So that edge should be where we mostly are cutting on, and maybe a little bit of that radius right there at the tip. The next two tools we're going to talk about are grooving tools. These tools can have, they both are shaped a little bit different on the ends here. There's a top-notch groover, and this top-notch groover here has an angle. And I cut a little bit of an angle on this one to remove some material. And this little insert is right here, is this little gold thing. And we're mostly cutting on the end here. That's where you can see all the wear is at on this tool. Same with this one. These are, even though they look a little bit different on the ends, it is basically the same tool. Minor differences might be the width here and the width here. They might be different widths. They have 1 millimeter, 2 millimeter, 3 millimeters, so on and so forth. I don't know if they might go down to a 0.5 millimeter. I don't source anything that low for the machine shop. Over here, our very next thing we have is our chamfering tool. This tool is sticking out really long because it's not a very big chamfer tool, and we have to get into certain areas, and we need the distance there. The part that does most of the cutting on the chamfer tool is usually on this edge here, not the tip here, not the corner here, not the corner there, but really just on this edge where the pen is, in between both of these corners. Or sometimes we actually use this side too. Sometimes we're cutting in between on this edge in the middle of it. So the spots I usually aim for when I'm cutting with this tool on a chamfer is usually you can kind of see there's like this flat part right in there on the chamfer tool. Go ahead, I'll move this back out and refocus. Hopefully we can get a good focus here. Yeah, very good. It's pretty good. You can see there's like a little indent right there. That's where I usually aim for in the chamfer tools when I'm putting it up against the edge of a part. It makes a 45-degree angle. This tool here is a general turning tool. We don't use it a lot because it gets in the way of our live center and the end of our part. So this tool you can use for facing and general turning. It's a great tool if you have the room to use it. If you're making a short part, this is an awesome tool. It can really clean up and do a lot of work. The next tool is the knurling tool. This is a medium knurl, cobalt 21 knurls, or 21 pitch or pitch count. It's 21 impressions or forms of a diamond knurl per inch. And it's a scissor knurl, and how it works is your material the goes in between here, and you hold it by tightening up the nut on this end. I'll zoom out a little bit so you get a better idea of what I'm talking about. So your material will go in like this, and you tighten it up, and this part will turn and move and translate. So it'll rotate and translate, and it'll put on this diamond knurl. Our usual feed rate is 10 thou per rev, and you can this thing can go pretty fast. I recommend going slower with it so you don't have a crash. 200 to 300 RPM is great. You can go faster, you can go slower, and still end up with a great knurl. So just some food for thought. This last tool is a triangle insert. This tool is great because it has 3 cutting edges, where a lot of the other ones I showed only have 2. You can cut on 3 edges, and it's a really robust tool. Same issue we have with this one. We run into we don't have a lot of clearance between this tool and our live center. So this is just another tool. These 2 tools we just don't commonly use. This insert here is a little bit different and a lot sharper. This is used for nylon and brass. So this is a great nylon brass tool. I want to kind of come back to some of these shapes. So these 3 tools are all going to do the same thing here. Let's move these out of the way. These 3 tools are all for general purpose turning. They're just have a niche between them. This tool and this tool are going to last longer because there's more material supporting the insert. This tool isn't. So you're going to have a lot quicker wear. But this is a great tool for making unique shapes out of metal, making round contoured surfaces, or getting into small areas. This tool is the tool you want. You don't have a lot of room to get in a small area with a tool like this or a tool like that. You're going to crash your part or your live center or your tailstock or something with this big lunking thing over here. Over here you have cuttable surfaces, really ideally on just this side, but also on this side. I also want to talk about inspection of your tools. So basically you're going to be generally turning with these tools a shoulder, which would end up kind of looking like this on paper. I actually have a part I'm gonna get out here, and this should show you what a general shoulder kind of looks like. This is a part that was turned by any of these tools here. So the tool's going to come down, and it's going to be basically, it's going to start off big like this, and then we're going to turn it around, and this tool is going to go ahead and cut it all the way down here and cut virtually a shoulder. Same with this one. This one we do the same thing. You can turn this and up to the edge, and then the tool can translate off of it. Same with this one. They can cut down here, and then the tool translates off of it on the x-axis. While the tool is cutting, the tool cutting in this direction is Z. This direction away, as the tool moves away, is on the X. X is diameter, Z is length. So it's just some information for you. To give you a general idea of what these tools are capable of. All 3 basically do the same thing. This is our primary tool. Tool safety. This tool is set up correctly. I'm going to move these ones out of the way. When I look at it, the distance from this plane and this plane are parallel and equal all the way across. I'm going to go ahead and I'm going to move this over here so you get a really good idea. You can really clearly see, even in the video here, that this is nice and safely set up. It's secured by all 4 screws. On the other hand, this tool is not. Right away, you can see that even when the camera, without even zooming in very far, that the distance from here to here is not equal to the distance from here to here. The tool is sticking off. And I could tell right away, if we kind of look down in here, there's a big gap. There's a big gap down in this area in there. And that's also a major concern I have using this tool. So before using it, you want to go ahead and adjust your set screws. And probably this set screw right here that's backed up against here. is causing a problem. So you need to make sure that the part is not on an angle when you're ready to go ahead and cut in the shop. The last thing I want to, so that kind of highlights that this tool is also safely set up. It's nice and flush all the way, and is equidistant, or basically parallel. The tool is parallel to the holder all the way across. So the distance from here to here, these two planes and these two planes are equidistant. Let's look at these tools next. These are our grooving tools. These tools can be used for general turning and for light duty turning and general light duty. And this one has the same issue. It's sticking out a little bit on this corner. This one looks pretty safe and pretty secure and nice and uniform all the way across. But this one's definitely sticking out a little bit. So this one needs to be adjusted also. Loosen the set screws here and then clean out the holder here and then readjust the tool. But I want to kind of highlight these tools. These tools are for grooving and making a groove in a part. And I'm going to show you a part that I have here. These tools were used to make this groove right here. You can kind of see it. Oh. So that groove right there that is made in this part, and we usually make grooves for thread reliefs, like right here on the part, or maybe even right down here. We put another groove down here on this end of the part, and we use these thread reliefs or these grooves to relieve the threads. You can see one groove is right there, one groove is right here, and another groove is right there. There's 3 grooves in this part that were made with these tools. So that's what these tools do. They're mainly just for cutting in on the diameter and putting a groove in. They're not really meant for translational or cutting on the Z or the cutting along the Z axis. Is mostly just moving in on the X, move out, move over a little bit, and put another groove in. That's what those tools are used for. Give you an idea. One of the last tools we're going to talk about today is the knurler. The knurler put on this knurl right here, this nice, beautiful diamond pattern you can see here. And to use it, you first start by loosening it up. You can loosen this a little bit. This one doesn't need to be super tight, just needs to be hand tight. And these ones over here, if you're knurling steel, you usually want to give it 1 full rotation, which is basically 2 half rotations, tightening it. So you're going to tighten it up by hand. And then this edge here, I'll put a piece of tape. This is what a full rotation is. I made like a little flag before I started making this video. 1 full rotation means that this piece of tape is going to go all the way around back up to that point. So that's what 1 full rotation would do. Would be 1 full rotation tighter. You don't always need to tighten this top one up, but you can just, if you do, this is just to lock it in. So you can go ahead and lock it in, but it could just be finger tight. You don't need to get it any tighter. So this once you get this finger tight, this one won't back up. But I rarely almost never use this top one. We'll go into knurling at another point, but this is just what the knurler does. The last but not, actually I got 2 more tools I want to talk about a little bit more. This one is the chamfering tool. This one puts a 45-degree angle on your part. You can actually see, if I zoom in really closely here, on this part, you can see right here on this edge, we have a 45-degree angle. That 45-degree angle, actually I'm going to come on over here, this 45-degree angle and this one here, probably see it even better like right about there right now, right? That 45-degree angle there was made with this tool. So this tool kind of comes into here and cuts that little angle there, and came over here and cut this angle there. That's what this tool does. That's why it's at a 45-degree angle. So just to chamfer the edges, take off sharp edges of parts. The final tool we're going to talk about today is this one, is our parting blade. Last but not least, this is the weakest tool in the shop. This is also meant to cut the length of a part. So we're going to come in and we're going to go ahead and cut the length of a part. You'd use this tool here. comes in on the x-axis. We don't translate left or right with it. We just come in on the x-axis and cut a part off in the machine, and then this will be the final length of the part. This is the last operation ever. We always use, I would say like 90% of the time, this is the last operation, this tool here. Is very weak, and the cutting end is right here, this tip right there. So we don't cut unless there's a tip in there. So it kind of gives you an overview of all the tools we use in the shop.